didn't see you there. I was just soaking up those sweet, sweet gamma rays from that nuclear explosion. Nuclear fission is an extremely energetic process that produces loads of energy. Now imagine if we can harness that energy and contain it. We'd produce tons of power. But what exactly is nuclear fission, and how can we use it? Well, nuclear fission happens at an atomic level. And it all starts when a neutron strikes a uranium-235 atom. Now that uranium-235 plus an extra neutron makes it into a U-236 atom. And U-236 is highly unstable. So it instantly splits into a bunch of heat. It gives off gamma radiation, which can heat up the water molecules around it. And it also splits into krypton and barium. And then it gives off 3 neutrons. And those 3 neutrons will go on to continue the reaction, hence it's a chain reaction. And this gives off a lot of heat, like I said. So it's going to heat up the water around it, which is going to turn the water into steam, which will produce power. We'll see how that works in just a second. What we just learned was that nuclear fission creates a lot of energy in the form of heat and gamma radiation. Now both of those strike water molecules surrounding it, turning the water into steam. The steam is run through pipes around the power plant, and it ends up rotating a turbine. Just as this water right here causes this beach ball to rotate. They're both fluids, and so they work the same. Now, the difference between this beach ball and a turbine in a nuclear power plant is that there's magnets on the edge of the turbine, and those moving magnets in a circular pattern induce an electric current within the wires surrounding it, and this creates power. So we have a way of directly converting nuclear energy into electrical energy, thus powering whatever you want to power it. Okay, so now that we know that nuclear fission is a viable source of energy, let's go over the pros and the cons of using nuclear fission over other sources. So some of the pros include that there's a high net amount of energy from each pound of uranium compared to things like coal, and there's 0 net carbon emissions from the actual process of fission. Another pro would be that the likelihood of a disaster in a plant is very, very slim. But of course, if it does happen, there will be disastrous consequences. And that leads us into the cons. Of course, if there is a meltdown, it will have a huge impact on the environment. And then another con would be that it is extremely expensive to maintain and to build compared to other sources. And another con would be that the uranium you mine has to be enriched before it can be split. And that takes a lot of energy in addition. So when you add up the mining and the enriching and the fission process, it overall equals a low net energy yield for nuclear fission. Additional con to nuclear fission would be the radioactive waste it creates. I don't know about you guys, but I like my uranium depleted. Unfortunately for my wish, it takes 10,000 plus years for uranium to get to safe levels. So, we need to store it in secure places. Unfortunately, the way we store uranium is not guaranteed to be safe that long. But we are doing the best we can. And you don't really have to, it's a huge negative to have to store all these things of radioactive material. But anyway, that's the pros and the cons of using nuclear fission. So definitely consider it. Yeah. So it seems that nuclear fission has its ups and downs. But if one thing's for sure, it does pack a punch. Now let's make like 2 uranium atoms and split. Catch you later.
I'm gonna dig as the boy. Gonna dig uranium high on the mountain top. Hey, gonna dig uranium high on the mountain top. When the castle for the